Hey, welcome back to Dang Square. Today I'm going to make a quick video explaining how I did, or how I built, my loop control pedal. I had a comment on the video that I made of it saying how, and wanted a tutorial, which, cool, no problem, can do. Some changes I've kind of done since that video. I think I might have upgraded it or changed it since then, but I'm going to kind of go how I built it. First off, it's just, simple punch holes into an Altoids tin for your power and your 4 input jacks, and then the button on the hole on the top for the button, whatnot. Now, most of the build of it, other than putting the parts on the can, is the wiring of the switch. That's the main part of the whole build. Now, in the last video I said I used one of these, double pole, double throw switch. And I kind of did. And I'm going to explain how that works with this. And also I'm going to talk about a triple pole double throw switch as well. That is now actually in this. I actually changed the button again to a 9-point triple pole double throw switch. I'll explain how that works. Alright, so this is the double pole, double throw switch. And the way this works is that this switch is actually controls 2 things at once. And you got controls on this side and controls on this side. These points adjacent to each other are not connected. They're actually connected this way. And I'm going to use a meter to kind of show this. We check the continuity of your switch. You can see that on one side, depending on which way the switch is facing, you have continuity. Now, if I go from this pole to this pole, you'll see there is no continuity, because this thing is completely half and half. You're on this side, and that's it. As for this side, you can see the center peg and then the bottom peg. There's continuity there. And this side controls one thing, and then this side controls another thing. So, flip the switch, you can see continuity changes from the bottom to the top. Solder's kind of getting in the way. And it does the same on the other side. So double pole, no matter, depending on where you have the switch, it throws the pole to either this side or this side. So your center is your home base for your controlling. So the way I had it is your input for, say, your signal is going to go to the center point. And then either this point or this point is going to go your bypass, or this point will go, and then the other point will go into the loop. So when the switch is flipped this way, you're bypassing the entire loop. Then when you flip the switch and go to here, it's going through the loop and back into the out. Now, same for the other side. I can use that for the LED light. It's a little different because the LED light doesn't require a loop, so it just requires is on and off. It's not necessarily for direction. So you're connecting your home base with your hot, and then take either this leg or that leg, depending on which adjacent to. If you're trying to signal that, hey, your loop is on, you connect it with this adjacent side to, hey, this is a loop side, so this is where I want the light on. So you're hot in and then out for your light on, and then this side will be nothing, it won't be tied to anything. That will open the loop or the circuit and turn off the LED light. Now, for this method, it's not exactly a true bypass, hence why I upgraded the switch to a 9-point triple pole double throw switch. Now, this is not the exact same one as the one in the switch, because this one has the built-in LED. I had a bunch of these come in. I had ordered a bunch of these, so it's got all the wiring stuff for the LEDs on it. This one it's the same switch more or less, but the LED is actually separate from it, and I'll show that wiring in a minute. So with this, you can get a true bypass. Now it's the same methodology, except you have an extra control on the switch. So instead of just controlling 2 things, it's going to control 3 things. Like I said, your center post, you can control the top or the bottom, and the other centers are not connected. So this center goes to that one, this center goes to that one, and then you flip the switch and it flips sides. Sorry, I'm kind of trying to keep a balance here on my camera, I apologize. So that's how this works. Now with this, what I'm able to do is use the left and right side for the same kind of thing to create a true bypass. So you'll have an in here for your main in, and if I want to do, say, for actual bypass, have the switch, when it's in the down position, go from here and connect this point to this point. Let's use this. Connect this point to that point with 1 wire, and now create a true bypass. So you come here, switch to here, it'll go to here, and then this will go to your out. So when you activate the switch, this switch transfers, the pole will go to here, this will go out to the loop, and you'll come back into the loop here, and this will go back to your out. So that way, this is your home, and then you're either going bypass or to loop. Now for the center, that's where you'll use the LED. The same thing, you'll come hot in, and if your loop is on this side, you'll out for your to close the circuit, and this one will be open to nothing. So when it goes to the switch goes to here, it closes, it opens the circuit to turn the light off. So that's how your true bypass works. Come in here, bypass this, go out, come in here, loop in, return loop, out, and then your switch will be on, off. So that's how, when you have something that's true bypass, this is why it's true bypass, is using this switch, type of switch. Now this has, like I said, the built-in LED on the in the switch, which makes it a little bit pricey, but it's actually pretty cool. That's one less thing I got to do, and then that just goes on top to light up for the LEDs on the on the 10 or whatever switch. So that's how that works. Now the way I wired up the switch, as you can see, it's your here to here, the bypass, and this is your coming in for your signal. This is the send to loop, that's your return to loop, and that's the out. And the yellow and red here is for the switch, or the LED. Now, and this is just a hot for the LED. The negative of the LED goes straight to the power source, to your to the 9 volt. Where's that? There we go. To the 9 volt piece. So you'll have 1 wire going into your hot. So 1 wire from the 9 volt will go to the switch, and then from the LED, the negative goes straight back into that power source. So that's how that's wired up. So this is, like I said, it's not the double pole, this is a triple pole switch. This gives you a true bypass scenario. So that's how that works. So looking at the whole thing, your input on the right here, and then you either, when you're in the bypass mode, just go straight across, or if it's actually activated, send, return, out. So, and that's how my Altoids loop LCP loop control pedal works. This is a utility pedal. There's no effects in it. Most of the pedals that I build that are Altoids pedals are all just utilities pedals. I have built other little pedals just for experimentation. Like this is actually a little amp, a mini amp Altoids 10 that I try to build. It's not the greatest, but it's alright. I need to actually get another speaker for that. And I do have the little fuzz pedal that I built, but all that's off of a pre-made circuit board. Most of the pedals that I've built or these utility pedals. Like this is a loop one, this is a AB switch. All it does is your input and changes your output between here and there. And I have made an ABY switch before. Quite complicated for an ABY switch. But yeah, anyway, I know the question was for my loop channel, or loop control pedal. That's how I make it. Y'all have a good one.